Good morning, ladies and gentlemen. I am Professor David J. De Los Reyes. The date for this morning will be March 12, 2025, and the time is 1:39 a.m. Okay, my topic for this morning will be a continuation of my long video format topic, analytic geometry. We are almost done with analytic geometry, because the topic for this morning will be the last topic on the so-called conic sections, and this is hyperbola. Okay, let's proceed. My subject matter or my lesson for this morning will be analytic geometry, lesson number 25, and the title of the topic will be the study of a hyperbola. The location of the center of that hyperbola is at the origin. Okay, the first topic under hyperbola will be the parabola. The location of the center is at the origin, or meaning the location will be at the coordinates 0, 0. Like this one here. The center of the hyperbola is actually at the intersection of the x and y-axis, and that is termed to as the origin. So for this morning, the first figure will be this one, and I will just be giving you the equation of this one. We will take it gradually, because there will be 4 topics under hyperbola. I don't go with the second one for this morning. I will just discuss the first one, that is meaning the transverse axis. This A here is along the x-axis. That's the topic for lesson number 25. The next time around, we will be reversing this one. The transverse axis will be along the y-axis. So for this morning, the transverse axis of the hyperbola, this is the hyperbola. The transverse axis A is actually along the x-axis. So on the standard equation, before I will try to define what is a parabola, the axis of this equation here is along the x-axis. And the equation of this one is actually x squared over a squared minus y squared over b squared, and this should be equal to 1. Okay? If you try to notice it, the equation is actually similar to the equation of an ellipse, or similar to the equation of a circle. The only difference is that under the hyperbola, this sign here is negative. Okay? So for a hyperbola, the sign on the middle is actually negative. Okay, let's try to define what is a hyperbola. I just wrote on the board the definition of a hyperbola. I will try to read it. The set of all points, the difference of its distances from 2 fixed points is always positive. The 2 fixed points, if we will try to see the figure, the 2 fixed points on the parabola is actually this one here. Fixed point number 1, focus number 1, fixed point, focus number 2, and according to the definition, if we try to graph this hyperbola here, this left portion, if we try to take the distance from this point here to here, and its distance from the other fixed point, this one here. This is the first distance, okay, and this is the second distance. According to the definition of the hyperbola, if we try to subtract this distance here minus this, what will come out will always be positive. Okay? It is something like this. If you try to move the point, supposing the point goes here, the longer distance will be this one here, right? And the shorter distance will be this one. Again, if we try to subtract it, it will still be always a positive, meaning a positive number. So as the point moves along the path, okay, if you try to take the difference in distances, it's always positive. So if you try to complete the curve, that will be the curve, considering the left-hand side. If you go on the right-hand side, it will still be the same difference. If this is the point, the longer distance will be this one here, from this to the point, and the shorter distance will be this one. Again, if you try to take the difference will always be a positive. So as the point moves along the curve, considering the right-hand side, okay, again, if you try to take the difference as the point moves along the curve, the difference is always a positive number. And that is the so-called hyperbola. Okay? It's easy to remember. The set of all points as the point moves along the curve, if you try to take the difference of the longer distance minus the shorter distance, from these two fixed points, the difference will always be positive. That is hyperbola. And if I will try now to bring out the first equation, because I will subdivide this one into 4 topics so we could visualize the difference of the 4 topics. The first equation will be this one. The standard equation will be an x squared over a squared minus, the sign here should be minus for a hyperbola, minus y squared over b squared, and this should be equal to 1. Right? So if this x here coincides with this a, the axis of the hyperbola will be the x-axis. And where is the axis of the parabola? For this one here, the axis of this parabola here, for this given figure is this one, the y-axis. Because it divides the first curve and second curve equally. That is termed to as the axis of the parabola. So for this one here, the axis is actually the x-axis. Because this line here subdivides the left curve and right curve into 2 equal curve, right? So this is the axis of the hyperbola considering this equation here. Okay? And the designation of the figure, it's all in here. The 2 fixed points are actually designated F1 and F2, and that is actually foci. This came from the word focus. Foci is actually the plural of focus. So if we see focus or foci, there will be 2 fixed points. The designations are actually F1 and F2. So the 2 fixed points, which emanates from the definition of a hyperbola, this is the first fixed point, this is the second fixed point. And if we try to bring out the coordinates of focus number 1 and focus number 2, that will be negative c and 0. This focus number 1 here, from center to focus number 1, the abscissa is actually negative c. It is to the left, right? And since it is along the x-axis, the ordinate will be 0. So if you try to notice is focus number 1 are actually the coordinates is actually negative c and 0. And this negative c here is different from this capital letter C here. That's why on the center, I place capital letter C, I place it here, center. Because there is another C on the equation. This is small letter c. and this small letter c is actually small. If it's small, it's not the center, right? But if it is big letter c, it will be the center. Okay? So the two fixed points are actually F1 and F2. And the coordinates are actually negative c and 0 and c and 0. If this is negative c and 0, of course, from center to focus number 2, this distance here will be small letter c. So this will be small letter c, and the ordinate will be 0. Right? It's easy to specify the coordinates of the main points on the hyperbola. What's next? For the center, okay, I place the designation capital letter C, and the coordinates will be 0, 0, because for the meantime, we are only discussing hyperbola in which the center is at the location 0, 0 or at the origin. So for the center of this figure here, the coordinates will be 0, 0. What are the next major points on the hyperbola? This point here, the point where the hyperbola intersects the axis of the hyperbola. This point here is a capital letter B with a subscript 1, meaning vertex number 1, and this point here will be vertex number 2, capital letter B with a subscript 2. So if we try to specify the coordinates of vertex number 1 and vertex number 2, these vertices here is actually plural, coming from the word vertex. If we see vertex, it's singular. So if we see vertices, that will be the plural form. Okay, I will try to check my camera. Oh, it's fine. So vertex number 1, vertex number 2, and if we try to specify the coordinates, okay, the coordinates of this one here will be A0. From center to vertex number 1, okay, this length here is actually A. This is A. So if we try to specify the location of this one, the abscissa will be, sorry, for this one, it should be negative A. It is to the left, right? And for vertex number 2, this distance here is same as this one. So the coordinates will be positive A and 0. So I will repeat it. Vertex number 1 will be at the location negative A and 0. Vertex number 2 will be at the location A, positive A and 0. Positive because it is to the right of the y-axis. This is actually negative A. This is positive A, right? What's next? So we are done with the focus or foci. We are done with these vertices. We are done with the center. There is a new term here, eccentricity. Under the concept of hyperbola, if we try to compute for eccentricity, this E here refers to eccentricity. And if we try to bring out the equation on how to compute for this one, for a hyperbola, okay, it seems we are given a right triangle. Okay, this will be A, this will be B, and this will be C. Okay, it will be coming out here. The relation of ABC is actually given by this one, and it emanates from this one. Right? For a hyperbola, I will repeat it. Eccentricity is actually designated by A, and if we try to compute for it, it will be the ratio small letter c over small letter a. And what is eccentricity? I took the definition of this one from Google. The simplest definition is that eccentricity is actually the so-called deviation from circularity. It seems it's a cousin of a circle. How far this hyperbola, if we try to compare it from a circle, that will be defined from the relation eccentricity is actually equal to C over A. So eccentricity is actually deviation from circularity. That's the simplest definition of eccentricity. What's the next one? Asymptotes. This is a new term also. Under the study of conics, there is the so-called asymptote. If we try to define, the simplest definition of asymptote is that it's a line that approaches a curve but will not meet the curve. It is something like this. This is the hyperbola. The asymptote of the hyperbola is actually this dotted line here. Okay? And this dotted line. So according to the definition, this asymptote here will approach the curve but will not intersect the curve. Okay? It will not intersect. It will just approach the curve but it will not intersect the curve. That's asymptote. Okay? And also, for asymptote, we need the equation of this one here. This should be a straight line and this should be a straight line. So for the hyperbola in which the center is actually at the origin, this is the equation of the first asymptote. It's an equation of a straight line that upwards to the left. So this is negative. And the equation of this asymptote here, because like what I said, it got two asymptotes, right? This is the first asymptote, this is the second asymptote, and the equation of the first one is actually y is equal to negative b over a times x. Straight line. We pass by straight line, right? An equation of a straight line upwards to the left is actually with the negative slope. So the slope of this one is actually negative b over a, upwards to the left. And the equation of the right one, it will be the reverse of this one. Y is actually equal to the ratio b over a times x. This is positive. Why positive? Because the equation of this asymptote here is actually upwards, or the how inclined the asymptote is upwards to the right. It falls under the first quadrant. That's why this is plus. Oh, that's the important thing under asymptote. Because sometimes there are problems in which they are asking for the equation of the asymptote of the given hyperbola. What's next? At least we should know what is a transverse axis. Transverse axis and conjugate axis. Transverse axis, if we try to go back to ellipse, it seems this is same as the major axis. Okay? And this conjugate here, if we try to go back to ellipse, it seems this is the minor axis. Okay? For a hyperbola, this length here is A. Okay, I will try to remove this sign. I just place negative because it is the left. This is also A. And this total length A plus A is termed to as the transverse axis. And this transverse axis is actually parallel to the x-axis, considering this equation here. So this is the transverse axis. This is the conjugate axis. Conjugate axis, it seems it is equivalent to the minor axis. So this is small letter b. This is also small letter b. So it seems it got a box in which the first length is actually 2a. That is termed to as the transverse axis. And the other side of the box is actually with the length 2b, 2 small letter b. And that is termed to as the so-called conjugate axis. And the last relation that is needed in the study or concept of a hyperbola is that small letter c square is equal to small letter a square plus small letter b quantity square. It emanates from this one. Oh, it is just something like this. It seems we bring out this triangle here. Right? This is the right angle. This is B, this is A, so of course the hypotenuse will be letter C. So if we try to find the relation of ABC, of course this is a right triangle. We use the Pythagoras principle, that is the square of the hypotenuse should be equal to the sum of the square of the two adjacent sides, A square plus B square. Okay, I think those are just the important things under the concept of the study of a hyperbola with center at the origin, in which the transverse axis is actually along the x-axis. So if this is x and this is a, the transverse axis is actually along the x-axis. Because if we try to change this one to y square, and this will become x square, the figure will be an upward like this. It will be the reverse of this one. The transverse axis will be along the y-axis if we try to change this one. But for the meantime, that will be the next topic. So I will bring this back to x square, and I will bring back this one to y square. So x square over a square, for a hyperbola, this should be minus y square over b square, and this should be equal to 1. The transverse axis, or the axis of the hyperbola, is actually along the x-axis. So the curve is actually symmetrical with respect to the x-axis. Okay, for this equation here. And the legend of the figure will be all of this, considering all the major points on the hyperbola. Center at 0, 0, vertices, vertex number 1, number 2, focus or foci, focus number 1, focus number 2, eccentricity. For a hyperbola, eccentricity will be the ratio C over A. And what is eccentricity? It's deviation from circularity. How far is it from the circle? And asymptote, the definition of asymptote is actually a line that approaches a curve but will not intersect that curve, or will not meet that curve. That's asymptote. So this is the first asymptote, this is the second asymptote. The length of the transverse axis will be 2a, this is 2a, and the length of the conjugate axis will be 2b. And the relation of ABC is actually c squared equal to the sum of a squared plus b squared. Okay, that's it, guys. So for those of you who would like to watch my channel is at youtube.com/@proofdavidj.de. If you want to share it, please click share. For those of you who do not know yet that my channel contains long video format topics on the major mathematics that is needed in the study of engineering, I just want you to know that I have already uploaded differential calculus, integral calculus, differential equation, advanced math, DC circuit, AC circuit, algebra and trigonometry, and PC machines. Okay, those are the long video format topics that I have uploaded. So for those of you who intend to study engineering, I think it's a good thing if you want to watch my channel. I'll assure you, you will learn something from it. Okay, for the short videos, since I know how to troubleshoot electronics, and I know hands-on up to the component level, I could assemble things in electronics. That's why if you watch my short videos, my topics are that sometimes I assemble some circuitry in which I uploaded it to my short videos. Okay, good morning from Los Angeles. This is Professor David Jeter.